Okay, so on to question number 3. What are some examples of oxidation numbers? So first, I'm going to start off by writing down the definition of what an oxidation number is. So basically, the oxidation number is the charge that atom would have if the compound that it's in was composed of ions. Okay, so I'm going to write down 2 examples. Let me make it a different color. So I'm gonna write down 2 examples, but before I answer them, I'll go over what the junior tutor said, because it might help us answer this question. Okay, so I have 2 examples. The first is aluminum sulfate, and the second is just hydrogen phosphate. Okay, so first I'm just going to read a few of the rules that'll help us calculate the oxidation number. So over here, the junior tutor has helpfully wrote down all of the different rules. The first one is that the oxidation number of a free element is always 0. So what they mean by a free element is that if it's in its solid form or its gas form and it's just something you find in nature and not a part of a compound, then its oxidation number will always be 0. Rule number 2, the oxidation number of a monoatomic ion equals the charge of the ion. Okay, so that makes sense. The oxidation number of hydrogen is +1, but it is -1 when combined with less electronegative elements. So basically when it is a hydride. Oxidation number of oxygen in compounds is usually -2, but it is -1 in peroxides. Rule 5, the oxidation number of a group 1 element in a compound is +1. Similarly, the oxidation number of a group 2 element in a compound is +2. The oxidation number of a group 17 element in a binary compound is -1. The sum of the oxidation numbers of all of the atoms in a neutral compound is 0. And finally, the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. Okay, so those are all helpful rules. So now this brings me back to our examples I have here. So I'm going to try and find the oxidation number of the atoms that are underlined in green. So in the first example, I'm going to write out an expression that will help us try to calculate the oxidation number. So on the left of the equal sign, I'm going to put a 0, which shows us the charge of the compound. So since this is a neutral compound, I'm going to write 0 on this side. And then I'm going to show how many of each ion there are. How many of each ions there are. So there are 2 aluminums, 3 sulfurs, and altogether 12 oxygens. Okay, so if we remember our rules, each oxygen atom has a -2 charge. And in the case of aluminum, it's not in the rules, but it has a +3 charge because it is in group 3 of the periodic table. So these are the 2 oxidation numbers that we know. And now that I know these oxidation numbers, I can plug them into our expression. So 2 times +3, I'll just write that. So now all I have to do is solve for the oxidation number of sulfur. I can do that just by using basic math. Okay, so I have calculated the oxidation number of sulfur to be +6. Okay, so let's try to do the same thing for the next example. Okay, so there should be H2PO4-. So since this ion has a minus charge, I'm going to put -1 on the left side of the equation. I'm then going to show there are 2 hydrogens and 1 phosphorus. And there's 4 oxygens. Okay, so again, from our rules, we know that oxygen has a -2 charge when it's not a peroxide. And we know that hydrogen usually has a +1 charge if it is not, yeah. So now I can plug it into our expression. And we are going to solve for phosphorus. Try to fit it at the bottom here. Okay, so then if we solve for P, we get that phosphorus has an oxidation number of +5. Okay, so if we look at the junior tutors examples, KCl, the oxidation number of chlorine is, I think this is supposed to be -1, and the next one it's supposed to be 0. Yeah, I'm going to just say that the rules of calculating oxidation numbers are correct. However, some of the examples given are incorrect. But all in all, I'll just say that this Solution is correct.